Ryan with Miss.Geek here, and this is going to be, I guess, part 3.2 of the VFO build for the BITX40. And what we're looking at here is just a simple diagram that I built myself to help me understand what connections need to be made between the Arduino Nano, the encoder switch, or the encoder switch, the RF and IF switch, SDA and SCL, and the SDA and SCL goes to the display, and also to the SI5351 breakout board from QRP Labs. So that board, it's ground all the way down until pin 7, except for pin 2 is not connected. Then it's VCC to pin 10. You also need VCC on pin 11. Yes, I know it's on the same row. I don't care. And then there's ground, SCL, and SDA. And then you've got clock 1, 2, and 0. So I need connections between SDA and SCL, which are at A4 and A5, and VCC for both sides here, which is also a 5 volt, is on the Arduino Nano here. So anyway, I need all those things, and I can also power it on the 5 volt. I take that back. You power it on the VCC, on the VIN on the Arduino. So I just was a note for myself. Anyway, so what I did is I took a board much like this one and used header pins, and then also a roll of this stuff. I used this really small pre-tinned wire, bare wire. This, I don't even know where you get this. I mean, I'm sure you can buy it on Amazon. I don't know what it's called, but a friend of mine, actually a coworker, an ex-coworker, gave me a whole box of ham stuff one time because he was no longer active and let his license lapse. And he was moving, and he says, "Ryan, I've got a box of stuff for you," and this was in it. And when this runs out, I'll be buying more because this stuff is amazing. So I'll show you what I've got here. I went ahead and put it together. I didn't actually build it on the video because it took hours. I'm not a fast builder. You have to understand. There's nothing fast about me. I take my time. I'm methodical. I'm slow at it. I'm not very good. I'm not very confident. But let me show you what I've got here. First off, let me unplug things. I should have had this unplugged already, but all right. And this is temporary. This is just a quick lash up so I can supply power from my power supply. So what we've got here is the Arduino Nano, the SI5351 board, rotary encoder plug-in, the switch for the RF IF switch, and then the display. And so underneath, I've just got my 7805 voltage regulator here with a couple of 10 microfarad caps for stability. And then that's what all these are here. They're not very even apparently, but these are 12 volts ground and 5 volts so that I can power anything in the radio from this right here. So that was something that's different from what I've done in the past. So everything will be able to be powered from this board. If I was really fancy, I would actually put in some power protection on this board. Maybe some reverse voltage protection. But I'm not that fancy, and I didn't do that. I haven't blown anything up from reverse voltage in a long time. But that being said, I probably will do so tomorrow. Anyway, so I've got those 5 and 12 volt buses here. The 5 volt bus powers, if you can kind of see this, let me grab a pen or something to point with. But the 12 volt bus, or the 5 volt bus rather, powers the VCCs on the SI5351 and also the VN on the Arduino Nano, and provides power to the connector for the display. And so you can see that there. It just kind of meanders around and it tries not to bump into anything. And then I've got ground here, which actually so it starts here. We got ground going to the Arduino that has a little jumper wire going over to one of the switches, and also there's a jumper going over here for the RF, or for the encoder switch. And I could have used a smaller wire there. I hot glued it in place so that it wouldn't chafe and rub on anything. So this ground wire here, it takes a different path altogether. You can see that it goes here and then goes there and then comes back out here and then goes there. So, and it connects somewhere else too, and I'm totally spacing it. Oh yeah, back here. So it actually starts here and then goes here, connects here, and then through here and around. So it took a bit of planning to make that work. Also, you'll notice that the SDL and SCA, they line up directly across the SI5351 board and the Arduino, and I left some room between them so I could throw the display board on there, and it's got power and everything. So that actually worked out rather tidily. It's a little bit of a tight fit. But I'll show you what we've got here for the rest. Now, I'm experimenting with my connectors. For one, for this I used a PCB and soldered on the connectors to the PCB and then the header socket to the PCB. That's as a strain relief. I've had pretty bad luck by soldering directly to the header sockets. They work free and they're flaky. And over here it's just soldered on normally, and then I braided that very poorly. Braided that actually. On this one, this is another cable that I made, and in another video I've posted just before this one a review of some wire, and this is all that wire. I've used it almost completely in this build, and I love it. Anyway, you can see I have directly soldered to the pin connectors. The main thing, though, is that I used hot glue as a strain relief, which I've not done before. So I'm hoping that the hot glue will stabilize it and simplify my connector builds. Of course, the right answer is to buy a crimper and crimp all this stuff and stop, hacking it. But we're trying to hack. So anyway, this plugs in here. And you'll notice that these are not quite the same. SCL and SDA are reversed at the board, so I had to reverse that. I also put the wrong connector on the first time, so I had to cut it off and do it again. All right, so let's get this thing assembled. Oh yeah, and it did the same thing, the same hot glue strain relief here on the RFIF switch. So we'll get that installed. Put the Arduino Nano in. Make sure I got all the pins in correctly. There we go. And let's light it up here. I love how flexible this stuff is. I really do. I'm like totally in love with it. Oh yeah, and that's the other thing. I didn't braid this one. I used little tiny itsy bitsy tiny weeny zip ties. They're kind of cool. All right, let's power it up. No smoke. All right, real good. So you can see it tunes. The IF, right now I'm tuning the IF, which 0592, so I can go up and this to adjust my, find the frequencies for my upper sideband and lower sideband by adjusting this. And if I press on this and do it, if I do long press, it goes up, the hertz here, and that tops out at 50 hertz. You don't really want to go more than that. And it bottoms out at 5 hertz. Which is probably about what you want. And then you press the RFIF switch button, and it switches to the RF, and that's 50 hertz down to 20, and then a long press brings it back up. So we can do 5 kilohertz and so on. So you can see the RF and the local oscillator. The RF is basically what you're tuning. The IF is what it's being mixed with, and that's so the local oscillator and the IF or BFO, VFO and BFO basically mixed together in the radio's mixer to produce this. So just to put this in perspective, here's the BITX40. The IF or BFO, beat frequency oscillator, connects here, and the VFO connects here. The microphone is modulates the BFO, and that goes through the crystal filter after being amplified, and then amplifies it again. And then the magic where all this stuff connects together is in the diode ring mixer. And the diode ring mixer sums and differences the local oscillator and the IF, so VFO and BFO. And the output is RF. So the trick is to find out what these crystals, what the shape of this filter is, and which frequency cuts out upper sideband and lower sideband, so that I can know what those can be, so I can either modify this sketch to use it as my main sketch, or get a different sketch and then modify it to fit my neat little VFO here. Thanks for watching, and if this is your thing, hit the like, subscribe, and tell your friends. So I appreciate you being here with me, and I'll see you next time. 73.